Hi, my name's Alan Smith. In this webcast, we'll explore the celebrity detection features of the Azure Cognitive Services Computer Vision Service using C#. I'll demonstrate how we can call a computer vision API and how we can use the celebrities domain-specific model to detect celebrities. There'll be a quiz, so you can compete against the service and see how many celebrities you can identify. We'll also explore if the service can be fooled by using a large number of images of Elvis impersonators. By using the computer vision service, we can take advantage of the pre-trained models that Microsoft has provided. In a scenario like celebrity detection, it would be challenging and time-consuming to train our own model using something like TensorFlow or PyTorch. So by leveraging the pre-trained models and consuming AI as a service, we're able to very quickly integrate AI into our applications. Bear in mind that the models are continuously improving, and as they mature, the results will get better. The code's fairly similar to the previous webcast I did, where we were just looking at the basics of computer vision in C#. What I'm doing is I've got a reference to the Cognitive Services Computer Vision library, and that's included in the NuGet packages here. And what I'm doing is I'm basically defining the subscription key and the endpoint to the instance of the service that I've got in Azure Portal. And this is the free instance of the computer vision service that I generated during the previous demo. So back to Visual Studio. The test data that I'm going to be using for this is from a Google search that I've done to be able to generate a folder containing many celebrities. And there's 774 images that we've got present in here. And the idea is that the console application is going to rattle through these images and it's going to sort them out into folders based on which celebrities it detects within those images. So there is going to be a quiz involved with this, and the idea of this quiz is see how good we are at detecting celebrities compared with the computer vision service. So I'm going to generate a new folder called quiz, and what I'm going to do is just basically copy 10 kind of randomish images from this Google search. So if I drop onto this thing here, I'm just going to go through. Actually, it's probably easier if I drop it on as a view it as a list, and then I can probably just grab 10 images here. Okay, so what I'm going to do is to move these into the quiz section. And what we're going to do is these photos are going to appear periodically as we are running through the webcast. And if you want to, just write down or make a note of celebrities that you detect. And then we're going to see if anybody can beat the computer vision service. I'm hopeless at detecting celebrities, so my score is going to be pretty low. So what we're doing in this method is creating a new computer vision client. This is the same as in the previous webcast. If I just press F12, that goes and shows the authenticate method to create the client. What I'm doing then is getting a list of the files in the input folder, which I've specified up here. We're printing out that we're analysing that particular file. Now, when I've tested this, some of the files are corrupt, or you could get a problem calling the service. Maybe it's not going to be a JPEG image, maybe there's going to be bad data in there. So I want to handle any exceptions and print out any exceptions into the console. So what we're doing here is we're basically making a call to the computer vision service. The call I'm making is analyze image by domain in stream async. And that basically means I'm passing in an image stream, which is the file I'm opening here, and the domain model that I'm selecting is celebrities. Right now, there's two models. We've got celebrities and we've got landmarks. And I'm testing with this celebrities model. Now, when the results come back, it will be in JSON format. So we need to serialize the object and basically create a J object that we can actually use programmatically. So for any celebrities that we've defined in the image, because the image may have more than one celebrity present in it, we're going to basically go through the detected celebrities. We're going to print out the name in the console. We're then going to copy the file from the input folder to a folder with that specific celebrity's name. So I'm selecting the name, creating a folder, and then just copying the file in there. So you should have all of the files with all of the different detected celebrities. However, if a celebrity is not detected, we're going to copy the file into the unknown folder. Okay, so let's run the application and see how well it performs. So it's going through the images quite quickly, and you can see that it is detecting quite a few celebrities here, and they're being sorted into the folders. However, it seems to have stopped, and the reason why this isn't working anymore is relating to the fact that I'm using the free tier for the Computer Vision Service. I'm going to cancel this. So this is the Computer Vision Service instance that I'm using in the portal, and you can see it's running on the free pricing tier. So if I go over to the pricing tier section, you can see that the free pricing tier only supports 20 calls per minute, and I've got a few hundred images I want to send through the service. So I've got a couple of options. I can put a thread.sleep for about 3 seconds in every call, which is going to be really tedious, or I can just go on to the standard tier. And the cost of that, this is actually in Swedish krona. This is going to be about $1 or €1 per 1,000 calls that I'm making against the service. So I'll swap it onto the standard tier, and that's going to improve the performance. So because it failed in that first run, what I'm going to do is to jump back to the directory. I'm going to go to the output folder. I'm going to delete all of these folders except the unknown folder. So let's get rid of those, and within the unknown folder, I'll get rid of those images that we've got there, and we can run the demo again. Okay, you can see it's rattling through these celebrities, and some of them it's not detecting any celebrities, but you can see in some of the images it is detecting more than one celebrity. So I'm going to pause the recording until this completes, and then we can go in and analyse the results. Okay, so that run was a lot more successful. It's good that I put the exception handling in here. You can see I was getting some exceptions being generated here. It's saying the file image 93 already exists, so it couldn't copy the file. The reason is that we've detected Tom Hanks twice in that image, so it actually is attempting to basically save 2 copies of the file in the same folder. But at least the image has been successfully copied once into the Tom Hanks folder, so that should be fine. Okay, so let's go and have a look at the results. So if you go into the out folder, you can see that there's loads of different folders that have been generated here. So we can see 50 Cent, Aaron Paul. It's detected just one person in that particular image. We've got Adam Sandler. And scrolling down, you can see that there's quite a few more that we've detected here. There's Arnold Schwarzenegger is appearing in that image there. They're quite low resolution images because I've generated these from a Google image search, and I do have a webcast showing how you can generate image data sets from Google searches. I'll drop that in the link so you can check that out. It's a very useful way of being able to just create your own quick data sets very easily using a Google search. We've got some politicians as well. We've got Barack Obama appearing in a couple of those. Bill Gates is appearing as well. We've got Boris Johnson, Boy George. And you can see that it's quite an extensive list of people that have been detected in those images. So let's go down and look at the unknowns. So you can see that 310 were basically with no celebrity detected. You can see that some of them, like this one here, has just basically got the eyes, so that's going to be difficult to detect somebody on those. I am no expert on celebrities. I don't really recognise any of these people, so they're unknown celebrities as far as I'm concerned. We do have Marilyn Monroe. However, this is an Andy Warhol painting. It's not a real celebrity. Obviously, this one isn't going to be detected very well. And images like this with lots of different faces on, because it's so resolution, it's going to be a challenge for the model to actually pick up on those actual faces there. Okay, so what I'm going to do is to work with this quiz. If I go to the out folder, I'm just going to select all of these folders, unselect the unknown one. I should really have written code to create the unknown folder if it doesn't exist. Or do that at the startup of the console application. It will throw an exception if that folder isn't present. Okay, so what I'm going to do is to actually go to the quiz folder here, and I'm going to basically point the application at this folder and do the same thing with the celebrity sorting again. So let's scroll up to the top, and the input folder is going to be quiz, and let's run this again. So this is going to go really quick. There's only 10 images that it's going to be analysing here, and we've got the results coming out here. And I'm going to browse back to the actual folder, and if we go into the outbound folder here, And just do an F5 into the unknown folder. You can see that there's 1, 2, 3, 4 that were coming out as unknown. So I don't know who any of these are, but please, in the comments, if you do recognise these people, mention who they are. Also, that must be Donald Trump there. It normally detects Donald Trump, but for some reason it hasn't detected him there. And there's a few other infamous celebrities in that one. But you can see here that it has picked out, I'll just run through these, it's picked out Adam Levine. Dolly Parton is being one of those celebrities there, so you can give yourself 1 point for every celebrity that you've detected in these images. We've got Elvis Presley appearing in that image there. Ice-T is also in that image. Jamie Duran, Jennifer Lopez, Jessica Chastain, Penelope Cruz, Russell Brand, and Will Smith is appearing in there. Okay, let's work out the scores for the Computer Vision Service. I'm just going to search for star.jpg in this folder here. And I'll count the ones that we've got. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they had come out in the known section here. So in the unknown folder, I'm going to look at how many celebrities weren't detected. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's looking like the Computer Vision Service got 10 out of 20, or 50%, or 0.5 as AI developers would say. So I think it's doing a pretty good job at being able to recognise these celebrities. Please let me know in the comments if you managed to beat that score, or if you know who any of these celebrities are that are in the unknown folder, and if you managed to get any of those right. So when I first heard about this celebrity detection service, I was very sceptical about how it could work and how it would recognise celebrities. Is it possible to fool it by, looking like a celebrity? What happens if you are the spitting image of somebody who's famous? Will it detect you as a celebrity? So I decided that Elvis was probably one of the world's most famous celebrities. He's also probably one of the most impersonated celebrities. So what I decided to do was to do a Google search for Elvis impersonators. I've got 668 Elvis impersonators of varying quality in this folder here. I might just clean up a few of these images because some of those are going to be because some of those are not of an actual person. So it's not really worth sending those ones through, but most of them do contain a photo of somebody trying to look like Elvis. So let's see if the Computer Vision Service can be fooled by Elvis impersonators. And what we can do is basically take the Elvis impersonators path, we can drop this into Visual Studio, and I'll hit F5 to debug this. Okay, so you can see it's rattling through these. It has picked up somebody's name. It wasn't Elvis Presley, Sean Clush, it's picked out. And then we've got Val Ramos as well appearing here. So it's looking like it's picking out other people who are not Elvis Presley. But so far, we don't see any of these Elvis impersonators managing to fool the Computer Vision Service. I'll pause the recording and we'll go and look at the results once this is complete. Okay, so that completed successfully. There is an Elvis Presley that has been detected. So let's go and look at the results and see if we can look into this in a bit more depth. So within the outbound folder, you can see that we've got a bunch of people that have been generated here. It's picked up Andy Kaufman. Andy Kaufman was famous for being an Elvis impersonator, as you'll know if you've watched the film Man in the Moon. We've even got Donald Trump. He seems to get everywhere. Yeah, so Donald Trump is apparently an Elvis impersonator. And we've got a few others here. Now, we did get some as Elvis Presley. So to me, they do look like they are actually photos of Elvis Presley. So some of the other ones that were detected, what I'm going to do is just copy a few of these names. And we can see that Andrew Portelli is actually an Elvis impersonator. And he's also been detected as being a celebrity. Question. Is Blake Rain an Elvis impersonator? Yeah, it looks like he won the Elvis impersonator competition in 1998. Okay, it's picked up Bruno Mars as well. I don't know why Bruno Mars is here. He doesn't look much like Elvis. Maybe this is just... maybe this one's being picked up here. But I don't know if he ever was an Elvis impersonator. We've got David Harbour. I don't think he's an Elvis impersonator. Let's try a couple more. Yeah, we've got Elliot Pilarm, who is a Swedish Elvis impersonator. So it does seem to be pretty good at picking up these various Elvis impersonators. And it's actually managing to recognise, not actually classify them as Elvis Presley, but actually recognise which Elvis impersonator they were. So I was really impressed when I actually demoed this. My idea was to kind of catch this out and have it classifying these people as Elvis Presley. But mostly it does seem to be actually identifying who these are, even if they are well-known or not so well-known Elvis impersonators.